Hi, in this video I'm going to go through Math 2008 question 5. So in this question we are told that Millennium School has 1,000 students and 1,000 lockers, and all of these lockers are in a line down a long corridor, and to begin with all of these lockers are closed. So the first student goes by and opens every locker, and then the second student walks down the corridor and closes every other locker, so they close locker 2, 4, 6 and so on. So at that point there are 500 lockers that are open and 500 that have been closed. And then the third student walks down the corridor and changes the state of every third locker. So they close locker 3, which had been left open by the first student, and then they open locker 6, which was closed by the second student, and they close locker 9 and so on. And all the remaining students walk by in order, with the kth student changing the state of the kth locker. And this goes on until all 1,000 of the students have walked along the corridor. Okay, so for the first part, they ask how many lockers are closed immediately after the third student has walked along the corridor. Okay, so let's have a think about what happens to a few of these lockers to get an idea of what's going on. So all of the lockers start off closed, and then after student 1 goes past, they open every single locker, and then when student 2 goes by, they close every other locker, so they leave 1 open, and then they close 2, they leave 3 open, they close 4, and so on. Then when student 3 walks by, they change the state of every third locker, so they leave 1 open, they leave 2 closed, but then they change 3 from open to closed, and they leave 4 closed, and they leave 5, and now they change 6, so that's going to become open, and so on. And now we can see there's a pattern for what the lockers are like after student 3 goes by. So if I cut this off here and here, then we can see between where I've drawn the blue lines we have an open lock and then 3 closed ones and 2 open ones, and then that repeats, and open, 3 closed, 2 open, open, 3 closed, and so on. So we can split all of these lockers up into groups of 6. Okay, so how many of these groups of 6 are we going to get in 1,000 lockers? Well, 1,000 divided by 6 is 166, and we get 4 left over. So we get 166 of these groups of 6 lockers in this pattern, and then we'll have 4 lockers left over at the end. So for the first 1 to 996 lockers, we have 166 groups of the OCCCOO pattern, and then after that the pattern is going to start again. So we get locker 997 is open, 998 is closed, then closed, then closed. And so because in each of these patterns we have 3 closed lockers, then out of these first 996 lockers we're going to have 3 times 166 closed ones, and then we see we have 3 closed lockers left over at the end, and that's equal to 501 in total. Okay, now for part 2, they want to know how many lockers are closed immediately after the 4th student has walked along the corridor. Okay, so let's do what we did before and have a look at the first few lockers and see if we can get an idea of what's going on and find some patterns. So this is the situation we were left in after student 3 went past, and then student 4 is going to come along and change the state of every 4th locker. So they're going to leave the first 3 lockers alone, then they change the 4th one, so the closed becomes open, then they'll leave 5, 6 and 7, then they'll change the state of number 8, and so on. And this time the pattern isn't quite so obvious to spot. So let's have a think about how long the pattern must be. So for the pattern to repeat itself, it's going to be like everything begins again. So the situation that student 4 finds themselves in is going to be the same as what they had at the very beginning. So the lockers that they reach next are going to have the same pattern as the ones they'd just gone past had before they changed anything. And also, when student 4 gets to the new lockers, they need to do the same actions as they did before. So the ones that they leave alone or change the state of need to be the same as from before. Now, the pattern on the lockers repeats after every 6 lockers, and student 4 is going to come along changing the state of every 4th locker. And so the first time we get an overlap in the pattern of lockers starting again and in student 4's actions is going to be at the lowest common multiple of 4 and 6, which is 12. So the pattern in the lockers after student 4 has gone past is going to repeat after every 12 lockers. So we see that's going to be up to here. And we can see that this here is the same as the beginning of the pattern again. So now we see we have this pattern repeating every 12 lockers. So how many lots of this pattern are we going to get in all of the 1,000 lockers? Well, 1,000 divided by 12 is 83, and we get a remainder of 4. So in our first 996 lockers, we've got 83 lots of our pattern. Then for 997 onwards, the pattern is going to begin again. So we have an OCCO from the beginning of our pattern. And so we see that because in our pattern we have 5 closed lockers and 7 open ones, and then we've got another 2 closed lockers here. So the total number of closed lockers is going to be 83 times the 5 in the pattern plus these 2 left over, which is 417. Okay, now for part 3 it says, at the end, after all 1,000 students have passed, what is the state of locker 100? So if we think about which students will change the state of locker 100, so the kth student changes the state of every kth locker, and so that means student K is only going to change the state of locker 100 if 100 is some multiple of K. But then if 100 is a multiple of K, then K is a factor of 100. So we see that locker 100 state is changed by every student whose number is a factor of 100. i.e. if we look at the factors of 100, then locker 100 state is going to be changed by student 1 and student 2 and student 4 and so on for all students whose number is one of these factors of 100, but not by any of the other students. So locker 100 starts off being closed, and there are an odd number of students here, there's 9 of them, and so the final student, student 100, is going to leave the locker open, because for the locker to end up being closed, it would need to be open first and then closed, so there'd be 2 actions and there'd be an even number of actions overall. So because we've got an odd number of actions here, the locker must be left open. And you can check, if you look at the action of each student, student 1 is going to come along and open the locker, then student 2 is going to close it, then student 4 is going to open it, and so on, until student 100 leaves it open. So because student 100 leaves locker 100 open, then none of the students who come after student 100 is going to change the state of locker 100. And so at the end, after all of the students have passed, locker 100 is going to remain open. Okay, and now for part 4, it says, after the 100th student has walked along the corridor, what is the state of locker 1000? So, like before, the state of locker 1000 is going to be changed by students whose number is a factor of 1,000. And because we're looking at what happens after student 100 goes by, then we want the factors of 1000 which are less than or equal to 100. And these are these 11 numbers here. So again, because locker 1000 starts off being closed, and there are an odd number of students that come along and change its state, then it's going to be left open by the last student, i.e. student 100. And if you wanted to work out what each student did again, We see that student 1 comes along and opens the locker, student 2 comes along and closes it, student 4 opens it again, until all the way at the end student 100 leaves it open.